Okay, it's just a little bit after 10. Welcome everybody to the Save Local Waters Concrete Washout webinar. My name is John McManus. I'm the administrator of the Claremont Soil and Water Conservation District and an active member of the Save Local Waters group. Save Local Waters is a group of stormwater districts, soil and water conservation districts, and municipalities that have been working together since about the mid-2000s to raise awareness of water quality issues in the Ohio River Valley in the greater Cincinnati area. We do a number of projects each year, one of which is going on right now at the Cincinnati Zoo. It's our annual rain barrel art project. Those painted rain barrels will be auctioned off starting April 20th online, and they are on display at Cincinnati Zoo right now. Beyond the Rain Barrel Art Project, we typically host 2 educational events a year and on a variety of topics. This one is the first this year, the Concrete Washout webinar. Our second educational event you may want to make a note of. It is our annual Stormwater Management Field Day we hold in Northern Kentucky near the flood wall. Part of it is on the B&B River boats. Some of you may have attended in past years. Last year, obviously, we couldn't put that on, but this year we are planning to go back to it. The tentative date right now for the Stormwater Management Field Day is Thursday, September 30th. So on that, you can watch savelocalwaters.org or our Facebook page for more information and updates. Well, I guess this is the time of our training sessions where I would usually point out where our refreshments are and where the restrooms are, but I think everybody's probably good on that. So let's get on with the webinar. Each of the Save Local Water partners has a discharge permit, a stormwater discharge permit from Ohio EPA that requires us to do a number of things, one of which is to implement an illicit discharge detection and elimination program. And when we were discussing topics for this year's training events, we thought about illicit discharges. And one of the most common discharges we come across, one of the most common complaints we get is discharges of concrete washout into the storm sewer system. So we thought this would be a good topic this year. I do want to thank both the Ohio and the Kentucky Concrete Associations for their help in organizing this event. Our first speakers, which we'll get to right now, will address concrete washout regulations, violations, and their impact on the environment. The second portion of our webinar will discuss the roles of the concrete industry and the producers in managing concrete washout at both large and small construction sites. But to get us going, we have 2 speakers. We have Ryan Weiss from Hamilton County Public Health. Ryan is a supervisor with the Division of Water Quality. He graduated from Ohio University with a Bachelor's of Science and has been a practicing sanitarian since 2014 and currently a supervisor in the Division of Water Quality. His team performs all nuisance investigations related to stormwater within the jurisdiction of the Hamilton County Stormwater District. Our second speaker is Matt Wooten. Matt is an aquatic ecologist with 24 years of experience. He works for the Northern Kentucky Sanitation District number 1. Matt has both a bachelor's and master's degree in biology from Marshall University in West Virginia. He's been working for SD number 1 since 2006, where he and his colleagues have established a nationally recognized approach to ecologically relevant stormwater management. With that, Ryan, I will turn it over to you and you can kick us off.
Thanks, John. Let me just pull up the PowerPoint here. Okay, so like John said, my name's Ryan Wiest. I'm a supervisor at Hamilton County Public Health. Me and my staff respond to all nuisance investigations related to stormwater. We also do government trainings. So thanks for joining us this morning. I know rules and regulations isn't necessarily the most exciting, so hopefully you've had some coffee this morning and we'll get started. So concrete washout, oops. Sorry. So what is in concrete washout? So most of you are probably familiar with what's in concrete washout, considering that it's what you do on a daily basis. I know some of the other people joining aren't necessarily involved in that, but it's mortar, plaster, grout, cement, slurry that's produced during construction activities. The slurry can become caustic and toxic when mixed with other organic compounds, and it's mostly made up of Portland cement. So those of you that work with this stuff on a daily basis, you're probably aware that if you get this stuff on your skin, it can cause burns and stuff. So it's, it can be a nasty chemical, and that's why why it's important and why we're trying to keep it out of local waterways. Just some facts and figures about concrete. It's the most common construction material in the world. Enough concrete washout material is generated each year to build an 8-lane highway from Cincinnati to Athens. And you could actually go a little further than that, but that's a lot of washout material being generated, and that's why it's important to manage it properly. Enough water is used annually to supply a city of about 50,000 people for 3 months. So that's about the size of Middletown if you're from this area. And 340 million cubic tons of ready mixed concrete used each year in the United States. So, it's a lot of material. And so if everybody, little by little adds up to being a lot of washout that gets into creeks and streams in these areas. So that's why it's important that everybody tries to manage it properly. Another reason it's important, it's filled with heavy metals. So as you can see on the screen, these heavy metals are mixed in with
Ryan,
that Portland.
I'm going to stop you for a second. We cannot see your screen.
Oh, really?
Yeah.
Sorry, I thought I hit share on the presentation here. It should be, is it not sharing my screen now?
It is not.
What about now?
It is going now. Give it one second. There we go. But it is in the notes presentation. So if you'll just, yep.
Okay, there we go. Sorry about that. I thought I shared and it was showing this on my screen. So catching back up to where I was. So these heavy metals that you can see on the screen here are all in concrete washout, and in Cincinnati, 88% of the drinking water in this area comes from the river. So, if people in Pittsburgh and Cleveland are doing concrete washout and they're not doing the proper things, and that washout's getting into creeks and streams, it's ending up in our drinking water. It's ending up in all the aquatic life, the fish that are in the river. So the Ohio River, obviously, people probably don't typically eat fish out of the river. And part of the contributing factors is concrete washout and all these heavy metals that makes it unsafe, to eat those aquatic animals. One of the most important things that I don't think people necessarily consider when they think of water pollution is sediment. So according to the EPA, sediment is the #1 pollutant of US waterways. And that could come from construction sites, including concrete washouts. And you guys are often on sites where you see improper sediment controls for, straw wattling or silt fencing. So that contributes as well. So when this material blankets stream beds, it suffocates the organisms that live in or on stream beds. And those organisms are the food for the larger organisms such as fish that live in those waters. So really, if you start at the bottom and you're suffocating out all the, micro and macro invertebrates that live in creeks and streams, it's tough for the stream to be healthy because the food supply has been decimated by sedimentation. It also increases, the cloudiness of water, which reduces the oxygen levels, which makes it hard for aquatic life to live. And cloudy water is also more difficult for water treatment plants to treat for drinking water. So increased silting and sedimentation just, increases the cost to the public to treat drinking water for everybody. Concrete and pH. So one thing, the reason it's, caustic, a high pH. So, an alkaline substance like concrete washout is nearly as a basic as drain cleaner. So obviously you wouldn't want to be putting drain cleaner into a creek or stream. And each increase on this scale is a 10 times increase in the potency. So, just going from 9 to 10 and 11 to 12, you're looking at a 10, 100, and then an 1,000 times increase each time you go up a few numbers on the scale. And a high pH in the water, for aquatic animals like fish, it kind of takes away the slime layer that protects them from pollutants in the water. So once you remove that slime layer, the fish are much more likely to take in pollutants. And when mixed with organic compounds like ammonia, which is in fertilizer, if you mix a high pH and something like ammonia, the fish aren't able to excrete the ammonia properly. So it really causes them harm and can kill a lot of fish. So a safe range is typically between 6.5 and 9. Like I said before, stripping the fish of their slime layer, and you see in the photo, that's what happens to fish when you get too much pH or a high pH in local waters. So uncontrolled stormwater discharges pose significant threats to the public health and the environment. Environmental regulations have greatly improved air and water quality over the past several decades. And some people and businesses over time have just proven that if there isn't rules and regulations, they just won't do the right thing. They're going to take the cheap route and do what's easy. It saves time and money, which, they're running a business, so people understand that. And getting into the rules and regulations, starting at a federal level, what gives, someone like me or other people in government the ability to enforce upon people who are causing pollution to the waters of the state? The Clean Water Act from 1972, it gives state and local administrations the authority to enforce the rules and regulations set forth in the Clean Water Act. And part of that requires construction sites to have measures in place to prevent pollution from being discharged into nearby waters. Getting down to the state of Ohio level of rules and regulations, a lot of these are going to sound kind of similar, but essentially, the Ohio Revised Code, the ORC, basically says nothing can be discharged into the waters of the state besides rainwater that would cause pollution. So anything from a construction site, whether it be sediment or concrete washout, is not allowed to be discharged to waters of the state unless you have a permit. And nobody that I know has an NPDES permit, which is National Pollutant Discharge Elimination System, to be discharging concrete washout and slurry into waters of the state. The Ohio Revised Code 370748 basically gives boards of health the authority to enforce rules, and if you do not follow rules implemented by the Board of Health, you're in violation of that Ohio Revised Code 3707. 3745 basically just states, similar to the ORC 6111, that water shall remain free from suspended solids or other substances that enter waters as a result of human activity. So obviously concrete washout is a result of human activity, and it's going to settle to form, sedimentation on the bottom of local waterways. And that's definitely adversely affecting aquatic life. Some of the local regulations in Hamilton County that we have, the Hamilton County Rules and Regulations, Article 2, no person shall discharge, cause, or threaten to discharge pollution to local waterways or to the MS4, which just stands for Municipal Separate Storm Sewer System, which is essentially just all stormwater infrastructure. So if you're discharging any pollutant into stormwater infrastructure, it's obviously making its way to the local streams. So you can't do that. And recently, Hamilton County, we have a sheriff that we'll work with now. If we don't get compliance with Board of Health orders that we'll send out to do enforcement, he's designated just to address environmental issues in Hamilton County. So we'll attempt to get compliance with folks, but if if we can't get compliance, we'll pull in the sheriff's office and he'll go out and document what's going on and take people to court on his own. So that's something new we've started doing in Hamilton County. Other rules and regulations in Hamilton County, these are the earthworks regulations. You must submit a stormwater pollution prevention plan to the Hamilton County Soil and Water Conservation District before you start work. They review those plans for, you're going to need BMPs and everything included in those to show that your project isn't adversely impacting waters of the state, or, sediment and stuff is not leaving the site. If they do inspections and they find that you are causing adverse impacts and not properly maintaining sediment and concrete washout and stuff like that, they can issue an immediate stop work order if you have an unpermitted discharge. So that's something to consider. They could show up on your site and tell you must stop work until proper controls are put in place to control the discharge of pollutants off site. And within those rules, they do have the ability to fine you up to $500 for failure to comply with their earthwork regulations. And one other option we have is if we get non-compliance, there's a pretty bad release, we'll call the Ohio EPA emergency response team, and they'll come down and they actually will charge the responsible party for their time and materials. So their hourly wages, their gasoline, vehicle maintenance will be billed to the responsible party if they need to get involved. And if sufficient response isn't made, the OEPA will hire their own contractors to come do a cleanup and then just send the bill to the responsible party. And those authority to do so is outlined in Ohio Revised Code 374512, if you care to look that up, and their phone number down on the bottom. If you do ever see anything or witness any bad spills going on, please call them and they'll send someone out as soon as possible to address those issues. Part of this I got with Warren County and Butler County to see if they wanted to contribute anything for their rules and regulations. So Warren County sent me a brief email about what the rules and regulations are for them. And, it's going to be very similar across the board from the state and to the local level. No person shall discharge or cause to discharge an illicit discharge to the municipal separate storm sewer. So obviously concrete washout is an illicit discharge, and any person who does that is subject, you would have to get an NPDES permit or you're not allowed to do so. And you would have to provide proof of the NPDES permit, but I'm not aware of anybody who gets or will be given an NPDES permit to discharge concrete wash water to the MS4 or waters of the state. And they also have the ability to show up on site and issue a cease and desist order if improper practices are being used that's causing an illicit discharge. In Butler County, this is information from their earthwork permits. It's going to be very similar to what you have for Hamilton County permitting. You must put sediment and erosion control BMPs, sock wattles, and catch basin protections. I'm sure you guys are very familiar with these things, and all that must be included in the building plans. The permit holder is responsible for the concrete washout, so whoever holds the permit is responsible to make sure that the contractors on site know that there needs to be a concrete washout area and the proper BMPs in place to maintain it. And they just use ODOT standards for concrete washout. Some of Kentucky's regulations and guidance, avoid dumping fresh and demolished concrete into water bodies. Don't dump concrete in vacant areas off the job site. So don't leave the job site and then do a washout somewhere else. Do not obviously dump concrete washout in ditch or drainage facilities. And one of the rules is to provide a minimum of 6 cubic feet of containment area for every 10 cubic feet or 10 cubic yards of concrete poured. So you must, on all construction sites, when you're doing concrete washout, there should be a designated area. I'm sure you guys are very familiar with that. And you should be sure that this area is not near surface water conveyances. You shouldn't see a catch basin near the concrete washout area or a curb. They need to be removed and properly contained on site, and that should be part of the planning when these things are developed. Like, where's the concrete washout going to be, not just an afterthought. And then potential issues with municipalities. Let's say, you have a bad concrete washout. If it damages the infrastructure in that area, the local municipality may not accept the pipes to be their responsibility until they've proven that the infrastructure is clear. So you may have to hire a company to run cameras through lines if there's clear evidence of bad BMPs before they'll accept the infrastructure, which obviously is a setback and costs money. So it can be easier just on the front end to manage those things properly. There's also a possibility of civil issues arising. So let's say you're responsible for damaging stormwater infrastructure from clogging pipes due to, concrete solidifying in pipes, and for some reason that caused flooding to a neighboring property. That person could potentially go after your company for property damage due to flooding. If water ends up in their house or damages any of their property. So that's something to keep in mind as well. If you don't remember anything else about what you can do with concrete washout, there's a little video that we've shown for younger kids, Freddy the Fish, and it's just really only rain down the storm drain. So really, when it comes down to it, you can't put anything down in the storm sewers, any of the catch basins or streams except rain. That's the way the rules are. So if you're on a concrete site and you see anything going on, please address it, or you can contact someone like us and we'll come address it with other contractors. And I asked Butler and Warren just to send us a few examples of pictures they've had, since Hamilton County will have examples later in the presentation. So this is just one from Butler County. As you can see, there's, but it looks like it wasn't really being used. This one, there is a concrete washout bin and they do have a designated area, but as you can see, the washout was occurring outside of the concrete washout areas. And this one, once the bins get 70% full, they're required to be emptied. So it's important to maintain them properly. A lot of times you'll see people have proper things on site, but as you've seen in these pictures, if you don't use them, then it's pointless to have them on site. And then this would be properly done after some back and forth with the county. An area that's gravelled and clean and not a lot of dirt is going to be being tracked off of this site. This is just an example of what you typically see, where the concrete washout accumulates in the curbs of the road, and then these obviously run down into catch basins, and then they get into the local waterways. So you can see down by the porta potty, it looks like there's a catch basin, and you can see all the sediment and washout material that's left this site. Here's an example where they have a washout area, but there is no washout actually on site. And this is just another example where you have a washout area, but it doesn't appear, maybe there's like a little effort there to have a washout in the back, but you can see all the concrete on the ground, so it wasn't being used properly. And this is just another example of, people really just not putting enough effort into making concrete washout important. You really need to know, for those of you that are in charge, that it needs to be a priority, and contractors and staff need to know that it's important. This is an example from Warren County. You can see they put the containment, they put up the straw, but then they put the tarp or plastic underneath the straw. So obviously the washout just runs out underneath, in between the plastic and the straw. So this isn't a proper way to set up a concrete washout. The plastic needs to be inside the container and overlapping the walls, obviously. Just another example from Warren County of really just not trying hard enough to build the concrete washout. You can't use silt fencing, isn't an approved way to maintain concrete washout. So that's pretty much all I have for my presentation. I want to give a thanks to Darren Martin and Warren and Butler counties for providing information for the presentation, and I'll pass it off to Matt Wooten. Thanks.
You need to share your screen there, and there you go. Thank you. All right. Well, give me just a second here, get set up. All right, well, thanks, Ryan, for passing that off. And I'm always honored to get to speak to folks about this. I'm going to switch gears just a little bit here and not necessarily talk so much to pinpoint the concrete washout, but just minimizing the impacts of stormwater runoff in general, and how we're managing that here across the river in northern Kentucky. So just a little bit of how this is going to go. I'll give you a little bit of background of the program that we've been building here for the last 14 or 15 years. We'll talk a lot about the impacts that are associated with some of the stuff, the approach that we built. We'll touch on some of the results. I won't go too biology nerd on you too bad, but I'll show you some of the things that we are seeing, some of the trends and so forth that we're looking at, and then talk about some of the impacts that we're seeing and things of that nature. You heard a lot about a lot of this runoff goes to the stream and so forth and so on. And so that's what this presentation is going to focus on, is what exactly we're protecting out there as far as the aquatic life is concerned. Now, typically when I'm talking to groups like this, I sort of start with a very basic question of, why do we manage stormwater runoff? And inevitably we hear, because we heard a lot about rules and regulations in the first presentation, we'll hear that, there's some entity or agency that makes us do it. Well, not necessarily the right answer. Obviously, we know that stormwater can cause problems, particularly as we move forward and we change our landscapes and things of that nature. One of the first things that we realized was that, we need to control for flooding. So flood control can be a real problem. More recently, we've been tackling the water quality issue. That's something you heard in the first presentation as well. We know that there are problems associated with stormwater runoff. We know that we can pinpoint some of them, like the concrete washout and things of that nature. We know that others are more challenging, some of the overland runoff issues, some of the sedimentation issues that we talked about. And speaking of sedimentation, one of the newer approaches in stormwater management revolves around channel protection. And what do I mean when I say channel protection? That's kind of like looking at the erosion of the stream banks that are associated with accelerated runoff forces. Yes, sediment can come from overland runoff, such as the concrete washout, such as construction sites, such as agriculture and things of that nature. And as Ryan correctly pointed out, sedimentation is the #1 leading pollutant in the country. It certainly is in Kentucky. But another source of that sediment can be the stream bank itself. Because we've changed the landscape so much, we've changed how often and to what magnitude and even what duration water is flowing through the creek. And so we can really accelerate the erosive forces and really have damage to our stream banks, and then the things that are nearby the stream banks and the things that live in the stream. So keeping that in mind, the sort of the basic foundation of the approach, the philosophy, I guess, if you want to say it, behind what we're doing revolves around what you see here. And this was something called a stream function pyramid. And this was first introduced by a guy named Harmon out of North Carolina, that I think does a really good job of kind of exemplifying how a stream functions. And basically what you're looking at is hydrology is at the base of that pyramid. When I say hydrology, what we're talking about is how water gets from the land to the stream. And the more that we alter that, whether it's through land use change or storm pipe introductions or whatever, the more you change how the water gets from the land to the stream, the more you're going to impact everything else in the stream. You're going to change the hydraulics, or in other words, how the water is flowing through the stream. It'll change the geomorphology. In other words, the rocks, the sediment, the stone that are in the stream. You may have a very diverse habitat, lots of boulders, cobble, gravel, things of that nature. If you really accelerate the water that's going through it, you can blow all of that out. It destroys habitat, that impacts aquatic life. physicochemical side of it, that's what we heard about earlier today. You know, there's the toxicity that are associated with things like concrete washout and the other things that are in the environment. The more you can change that, the more impact you can have. And obviously the biology is at the top. So what lives in the water is going to be affected the most by everything that's below it. So you might be thinking, well, how is that the baseline of the program? Well, when you think about it, as a stormwater utility, you know, one of the things that we have the ability to manage or just in somewhat control is how the water gets from the land to the stream. You know, that's why we have things in place like the concrete washout rule. So we're controlling how those pollutants get from the stream. We have stormwater management features like detention basins and retention basins and things of that nature that are controlling for the flood, for the channel protection and things of that nature. So if we can design our stormwater control such that we are minimizing the sort of separation of the hydrology from the natural, we can begin to minimize the impact on everything else above it. So that's basically what we're looking at here. So, you know, when we're talking about the impacts of stormwater, you know, some of the things that we obviously go to in our minds first are things like flooding. But what we're seeing lately is an increase in those impacts. They're more frequent floods. You know, oftentimes one of the things that I hear is that, you know, this never flooded before. Now, I don't know how many times I've heard that story. Or it used to only flood if XYZ storm came. And now we see these kind of floodwaters every time it rains. What's happening? So we have to keep those kinds of things in mind. You know, we're seeing impacts in areas that we never did see before. What's interesting about this picture is, you know, you're seeing a walking trail and you're seeing a manhole from one side of the story, but when you look at the other side, you're seeing the same one kind of from a different view. Again, when we change that landscape, you're really accelerating those erosive forces, and that's causing damage, and not just to the stream bank itself, but again, things near the stream bank. You know, you have a culvert that's going through here that's being impacted. You have a manhole nearby, which telling us that there's sanitary infrastructure that could be impacted. What's interesting about this picture is this is actually, there's an attempt to repair this once before. You can see that the stream had eroded, and at some point somebody installed something called a gabion basket in an attempt to stabilize the bank. A gabion basket is just a steel cage that's full of concrete or limestone riprap or just riprap rock. It's put in place to try to keep things there. But when you don't really take into consideration how the hydraulics of it and the altered hydrology, or, you know, how the water gets from land from the stream upstream, then you're not accounting for it, and the repair failed. So essentially, it's a Band-Aid. You're treating a symptom rather than trying to cure the disease. And we're seeing this across the region in Kentucky, and in quite severe cases. You can see the manhole bullet there is exposed. Now, I'm not a sanitary engineer, but I am quite certain that this is not how it was designed. You can see severely eroding banks along the edge there. That's a lot of fill that you're seeing being eroded and exposed. That could be part of the reason that it's even more erodible than the natural system. But again, it's impacting our infrastructure. And if you look real close up in here, you can kind of see that's a guardrail there. And that's because there's an off-ramp to Interstate 275 right above this. So while the impacts to our infrastructure, that is sanitary infrastructure, is important, you can see as if this erosion would continue to hit the toe of that slope, it could potentially lead to a landslide that could take an off-ramp to 275 with it. Now we're talking serious transportation impacts. So what I was getting at there is that the impacts go beyond just the erosive forces having infrastructure impacts on our, that is SD1, the sanitary infrastructure. We're also seeing impacts on some other things here. You can see here that the banks have eroded to the point where someone at some point built a retaining wall to try to stabilize it. The stream continued to erode, it continued to incise or get deeper, and the retaining wall failed. When the retaining wall failed, it exposed an electric power pole. And this is a rural road, and you can see a guardrail there where if this continues to slip, it will take the pole with it. That's, you know, that could lead to power outages for folks that live down this road. It could also damage the road. So again, we're seeing another impact to transportation infrastructure. And while this may seem sort of minimal in that it's a rural road with probably a few houses on it. This isn't. This is a Duke Energy power tree that the power company has had to move and replace 2 or 3 times over the years because of the severe erosive forces of the stream really moving stuff around. You can see that there's big concrete blocks here, big concrete barricades. At one point, this was a big concrete wall along this bank that the power company installed in an attempt to armor that bank to keep this erosive forces from happening. And as you can see, the creek continued to insize again, and the wall collapsed and fell with it. Believe it or not, and these are big stones. I don't know how much they weigh. These big blocks, 2,000 to 3,000 pounds probably, but I have found them further than a quarter mile down the stream. So water is extremely powerful and can really do a lot of damage if we don't manage it correctly. You can see this pipe here too. That's an abandoned gas line because it kept getting exposed. It had to be abandoned. So these impacts are far reaching and they go well beyond a single entity. Again, even more erosive power. This is a wing wall that goes underneath of the state highway as well. You can see how that's beginning to erode and really compromise the integrity of the stream bank, which can lead to things like this. That wing wall there, going under that state highway, the toe of that slope continued to erode the weight to the point where it couldn't hold up the weight of the road above it, and the road slipped, or the bank slipped, and it took the road with it. And it led to this wall having to be installed to repair it. So, these are costly repairs. While the same forces that are impacting the aquatic life within the stream are also impacting the infrastructure around them. So it's kind of a dual threat. It's really having impact on our aquatic life. And it's costing us a lot of money to try to maintain as a society. Now, I told you I'd go a little bit biology nerd with you a little bit. So I'm going to touch on some of the trends that we are seeing here and how these same forces that are tearing up our streets and tearing up our roads and things of that nature are also impacting the aquatic life. So we've been monitoring the aquatic life in Northern Kentucky, like I said, for about 15 years, and we've got about 75 different stations that we collect data at over the years. With those, and when I say information, this is the community data. We're looking at what lives there, what species lives there, and how many of each. And so we take that information, we put it in a statistical analysis, and the output that it gives us is kind of like a demographic survey. It groups sites based on how similar they are to one another structurally, and it separates them based on how dissimilar they are to one another. So when you take all that information, wrong way, and you put it together, you can see a clear urbanization gradient. That's because the sites that are all within this site, these are this circle, excuse me, those are all the extremely urban sites. And what that's telling me is that the aquatic community that lives there, they're all really similar to one another. When you look on the opposite end of this graph, these are all of the reference sites. So these are the highest quality sites that I have in Northern Kentucky. So they are all very similar to one another, and they're very dissimilar from each other. So with a lot of overlap in between. So you can really see that urbanization gradient. And when I said it's kind of like a demographic survey, you can kind of think of it if you were to look at the populations of cities. Midwestern cities would probably group out together. You put in Indianapolis, Cincinnati, and Columbus, and so forth. They'd probably group out together, but they probably group out separate from the East and the West Coast. So that's kind of how we're looking at it here. And again, you can definitely see that urbanization gradient, in other words, the more hydrologic or changes are really having an impact on the aquatic life. So I said we were going to talk about what we're protecting, and that's where we're going to go from here. So, we're out there doing our thing and monitoring the biology. We're looking for certain types of individuals, certain types of species that sometimes can be more sensitive than others. When you see those species that are more sensitive than others, it's encouraging that the water quality is good. Now, when I give this presentation, this is usually the time that it becomes interactive, and I'm looking out over the audience and I'm asking them, if anybody knows what this type of critter is. That's a little challenging in this format. So rather than wait for responses, I'm just going to try to walk through this and see if some of these things look familiar to you. So this particular insect, this larval form of the Dobson fly, is one of my favorites of the entire region. That's my hand that I'm holding it there. So this is a pretty big critter. And this is a helgramite, very sensitive to sedimentation. So if we're seeing a lot of sedimentation in the streams, we're not going to see these. Pretty uncommon in northern Kentucky, but there are a few high quality sites where we still see them. And if you're a smallmouth bass fisherman, this is the best smallmouth bass bait on the planet. So this particular one has been one of the best finds that we have over the years. This particular insect is a stonefly. Stoneflies tend to be very sensitive to the toxic side of the pollution. So again, getting back to the reduction of the concrete washout type of things. What made this one so significant is this particular species of stonefly had never been recorded this far north in Kentucky. It's extremely sensitive to water pollution, extremely sensitive to sedimentation. So the fact that we collected one of these in northern Kentucky was exciting for the biology guys like me, and it provided the nature preserves to add a range extension for this particular stonefly. So that's a pretty cool find. So starting at the bottom of the food chain and moving up, again, I'm sure we've got a lot of fishermen out there, folks that like to catch fish. And so I should point out too, that all the photos that I'm going to show you here are from the examples from northern Kentucky streams. So this is black crappie collected in the Licking River. Again, really nice sport fish that we see, again, representative of a quality fish population. This is a rock bass. This is one of the more common fish that we see in our local creeks and streams. Some people call them a red eye. There's other local names and things of that nature. Extremely popular sport fish as well. Fun to catch. Take a light pole with a spinner rod in a creek and you'll catch these till you're tired of catching. So this fish is another one. Similar to a walleye, the first cousin of a walleye. This is a sauger. This fish was collected in a tributary of the Ohio River, near the Ohio River, so it's probably a river fish. Tend to be a larger water fish. It's a top predator, pretty good size, which is indicative that it's eating well. Again, it's a top predator, so it's eating small fish. So if the small fish are eating well, then that tends to be a good thing. So again, this is a good indicator of a healthy aquatic community. Here we're looking at, pound for pound, the best fighting fish of all small stream fish. This is a smallmouth bass. This is another fine example of a true healthy specimen collected in a small stream in northern Kentucky. Again, give you an idea of a little better idea of the size of that fish. Just a good quality 14, 15-inch fish that we see relatively commonly. Just another good indicator that some of the steps that we're taking to try to manage our runoff and the components within it are doing a pretty good job. And the first cousin to the smallmouth bass is, of course, the largemouth bass. Another really good example of fish that you see out there that a lot of people think just don't exist in the Ohio River system. And this is a good 3-pound fish that we actually see pretty frequently. So again, this is just another good measure that the steps we're taking are working. And then moving away from the sport fishing side of things, this particular fish is one of my favorites in the region, and one of these species that I'm most happy to see. This particular species is called a blue sucker. And at one point in history, the blue sucker had all but disappeared from the waters from the Ohio River in general, and just in northern Kentucky and southwestern Ohio, primarily because the blue sucker requires clean swept gravel in order to reproduce. That's where it lays its eggs. Sedimentation had become such a problem in our local waterways that the availability of clean swept gravel just wasn't there, and the blue sucker was not able to reproduce, and the numbers went down. Since we've been adopting some of these better best management practices, we're reducing sediment loads substantially in our streams. The blue sucker is beginning to return, and I would not call this a common occurrence, but the fact that we're seeing them now is a substantial improvement over time. So again, it's just a indicator that the work that we're doing is working. We got to keep going, but we are having successes. So with that, we've had a lot of success over the years here, trying to implement some changes on how we're doing things, getting people to recognize why, these kinds of rules and regulations are important, why these kinds of things are important, why we're managing what we do. It's not just sort of a narrative approach that we should be doing it. We've actually got data to indicate why we need to be doing things, and data to help us identify our targets, our thresholds of what we need to be managing to. So, we've compiled a comprehensive data set now to help us make our decisions. We've identified the good, the bad, and the ugly. So we know where our good streams are, we know where the bad ones are, we know where the real bad ones are, and we've got a really good idea of why they're good, bad, or ugly, which really helps us define our management goals. It helps us define our thresholds, what we need to be managing to. It helps us with our decision tools. It's informed decision making. Again, rather than just a narrative approach that we ought to be doing this, we've got good reasons as to why. That helps us outline better rules, better regulations. Again, informed rules, informed regulations. It's not just we think this will work. This is an approach that is just data based. It helps us a lot with the regulators. They see this kind of thing and they know that we're in it for the real deal. And so, when you're able to demonstrate to the regulatory community that, that here are the reasons why we're doing them, they become a lot easier to work with. Now, it does not come without its challenges. Obviously, this is different. It's a change, and everybody struggles with change, and not just outside of the agency, but within the agency. Been doing things the same way for a long time. Sometimes it's hard to change the way things do. The lack of experience hurts us. Again, it's new, so there's just not a lot of folks out there that have done it in the past. And as we begin to implement these changes and show folks why we're doing it, it's starting to come around. And that also helps with the final bullet, the lack of political will. We all know that you can't have policy without politics. So getting in front of the folks that matter, the elected officials and things of that nature, and providing them with the same information of this is why we're doing this, this is what we're protecting, and this is why we're protecting it. It really makes a big difference on being able to move forward with that. So that's all I've got today. Again, my name is Matt Wooten, and if we're going to take questions, I'll be glad to take them.
Sarah, any questions coming in?
We currently do not have any questions,
Okay.
but if participants would like to unmute themselves and ask the question, they're able to do that as well.
All right, well, it doesn't look like we have any questions now. After our next session, we'll have another question and answer period. So if something pops up in your mind between now and then, feel free to jump in at the end of our next session. But right now, we'll get to the next portion of the webinar where we will discuss the role of the concrete industry and producers in managing concrete washout on both small and large construction sites. We have 4 speakers. The first is Jordan Bailey, Jordan is the environmental manager for Irving Materials, Inc., or IMI. He attended Western Kentucky University and received a bachelor's in geography with a minor in floodplain management in 2014. After college, Jordan accepted a position with the Kentucky Department for Environmental Protection as an inspector for the Division of Water in the Louisville office. In 2017, he transferred to the Florence Regional Office to be closer to his hometown of Burlington. And in July of last year, he parted ways with the Division of Water and accepted a position with IMI Kentucky as the Division Environmental Manager. After Jordan, we'll have Brett Ruffing. Brett is the Executive Director of the Kentucky Concrete Association, and was very helpful in helping us organize this webinar. Brett came back to Kentucky after serving various roles at the National Ready Mix Concrete Association in Alexandria, Virginia, most recently as Senior Vice President of Membership. Prior to joining the National Ready Mix Concrete Association, he served as the Director of Education and Technology at the Kentucky Ready Mix Concrete Association, now the Kentucky Concrete Association. Brett grew up in the concrete industry in Northern Kentucky, and through high school and college, he had hands-on concrete construction and supply experience. He's a graduate of the University of Louisville, is an accredited LEED Green Associate, and is a certified ACI Concrete Field Testing Technician Grade 1. The important stuff: Brett enjoys spending time with his family, friends, and his dog Maya, being outdoors on the water, traveling, and sipping bourbon and good wine. Our two other speakers are both from the Hamilton County Soil and Water Conservation District. We have Olivia Moultrie. Olivia joined the district's earthwork team in 2019. She's responsible for ensuring compliance with the Hamilton County earthwork regulations by performing site inspections for builders and landowners, and also responsible for ensuring compliance with the earthwork regulations by performing inspections. Also from Hamilton County Soil and Water, we have Aaron Habig. Aaron joined the earthwork team in 2016. Aaron assists landowners with drainage and erosion issues, and like Olivia, he's responsible for ensuring compliance with the Hamilton County earthwork regulations by performing site inspections. With that, I think, Jordan, I think you're first up. Is that correct? We'll turn it over.
Yes, sir. Share my screen really quick. You guys got it? All righty.
Yep, looks good.
If you're a producer, just go ahead and take a deep breath. It'll be okay. I know these folks are pointing out a lot of issues. And like John had mentioned, I am a former regulator. So my presentation will both cater to the perspective of being a former regulator, but also being an environmental manager for a producer in the industry. So some things that we're going to discuss today, we're going to briefly talk on the history of kind of how we got here and where we're going. What are the regulations and requirements that we as producers have to follow? What we particularly at IMI are doing to comply with these regulations and expectations, and kind of Concrete Washout 101, which will be a program that we're going to be implementing in the future. We will also be briefly discussing enforcement, and I know this will somewhat be repetitive to previous presentations or future presentations, but it's an important topic that needs to be brought to the attention of the industry and us as producers. So how did we get here? Well, in 1948, Water Pollution Control Act was passed, and this was really the first major law that addressed stormwater pollution. In 1956, this was amended, and specifically, this was amended to strengthen enforcement. Now, in 1965, This was amended once again, and this was to establish water quality standards that were enforceable by both state and federal agencies. But the problem is that there was a lot of reorganization and restructuring with these industries and with these agencies. Really, there just wasn't funding for states to develop water quality standards or to enact their own enforcement policies. And this really was standard till probably what would be noted as the single most event that led to environmental change, and that is the Cuyahoga River Fire of 1969. The Cuyahoga River runs from Akron to Cleveland, and it was polluted to the point to where it would catch on fire. Pretty nasty stuff. And as a result, you had the formation of the Environmental Protection Agency in 1970. And from there, shortly after, the Federal Water Pollution Control Act was amended, primarily focusing on enforcement, water quality standards, pollution prevention, stormwater monitoring, and agency funding. And this would be later known as the Clean Water Act. But what a lot of folks don't know is that the Cuyahoga River actually caught on fire 13 times prior to 1969. In fact, the 1952 fire caused $1.3 million worth of damage, whereas the 1969 fire only cost $50,000 worth of damage. So why was the 1969 fire so much more significant than the 1952 fire? And it really was, it got a lot of attention. Time Magazine posted a photo and an article of the event. So it got a lot of eyes, and in turn, a lot of people had concerns, which forced regulators and lawmakers to take action. Now, the same instance can be said for what's taking place today. And that is, times have changed. Advances in science and technology and availability of information has made it pretty easy to identify issues and concerns. Everybody's got one of these guys here, a cell phone, where you can post a picture, take a video, write a comment, and in some cases, it's seen by millions. I was speaking with one of our GMs up in the Ohio division this morning, and he said it plain and simple. If you're not willing to do the activity on video, live, in front of the world, should you really be doing it? And it's these types of advancements that has made it to where there's increased public awareness. And then from there, you get proactive regulators, increased regulations, and then the industry is forced to comply with these changing requirements. And it can be a difficult task. You just look how far how things have advanced over the last couple of years. We're certainly not utilizing practices that we were in the past. And I got some bad news. It's probably only going to get worse here for the industry. Well, I don't want to say necessarily worse, but more difficult to comply with regulations if you're not taking a proactive approach. So my position as an environmental manager is to kind of ease the pain and suffering during these transition periods. And it's to provide my folks with the knowledge and tools so that they can, succeed environmentally. And so where do you really start? And you really have to start with identifying what those requirements are. So typically, these are the laws and the regulations, and these laws and regulations, similar to the laws of the road, staying under the speed limit, stopping at stop signs, they're backed by legislation. The only problem is nobody goes and reads the legislation unless you're a lawyer. The reason being, it's difficult to comprehend. It's muddy, it's just a mess. So typically these are outlined in our local and state permits. So we've had some folks with our local communities, our MS4 partners, certain municipalities, and they typically have land disturbance permits that outline their requirements, also zoning construction ordinances. And I'll let those folks briefly touch on those in the next presentation. But at the state level, here in Kentucky, we have an operational permit, and this is similar to every state, but these requirements do vary. We have what is known as the KYG 11. Also, we have a construction permit, and that is the KYR 10. And I wanted to bring both of these permits into play because for the longest time, there was an industry issue of shared responsibility. Primarily, it was the producer or the concrete industry that was responsible for conducting these activities and making sure that these practices were maintained. But the state of Kentucky revised their construction permit to where there's now a little bit of shared responsibility. So regarding the KYG 11, it is an industry-specific general stormwater permit. And this caters to precast, ready mix, and our asphalt producers. If you are one of these producers, you have the duty to apply and hold an active KYG 11 permit. Now, in that permit, we have specific requirements to treat and maintain our processed wastewater and our stormwater, and specifically any water which during the manufacturing process comes in direct contact with product or use of raw material, intermediate product, finished product, byproduct, and all this includes concrete truck washout residual. Not only that, it also says no concrete washout material can be placed in the waters of the Commonwealth without going through treatment. Excess concrete is to be dumped in designated concrete washout areas only. So these are the requirements that as a producer, we are held to. Now, regarding the KYG 11, and this is for construction activities at or greater than 1 acre, it specifically states that wastewater from washout of concrete is absolutely prohibited unless managed by an appropriate practice, and that is known as adequate concrete washout. So what are we doing at IMI? Well, my hiring was part of an initiative. Essentially, we doubled our presence in the environmental department, and that was for a few reasons. One, we operate in 4 states, and in those states, there are actually varying requirements. I was kind of surprised moving from the public sector to the private sector at how great those variances are. And not only that, we needed and were wanting to have a greater presence on site, and that is essentially to identify issues and concerns before they get and reach non-compliance. So we're in the process of essentially rebuilding our environmental program. And part of that program, we're going to focus heavily on training and specifically with the drivers. The reason being is that the drivers conduct 99% of these activities. So we're going to train our drivers through a standard operating procedure on how to conduct these activities in a manner that is not only safe for them, other on-site personnel, and the environment. Like previously mentioned, if you get concrete washout residual on your hands or your body, it can leave burns, so it is a concern. So that certainly there needs to be appropriate PPE and where are these activities being conducted that they're safe for other on-site personnel in the environment. Beyond that, we train our plant managers and our production managers. And this is because these folks oversee driver activities. So if a driver is caught or seen, or for some reason are notified that these activities aren't conducted in a manner that we would like them to, certainly disciplinary action can be taken. And in a very proactive approach, we also train our sales reps, our project managers, and our dispatch coordinators. And these folks are trained to ask the question of whether or not adequate washout areas are going to be provided on site. And if so, where will they be located? And the reason why we bring these folks in is essentially we're eliminating the risk of non-compliance before a truck even rolls on site. So what does this standard operating procedure look like? Well, it's pretty much what we're discussing today. This is somewhat pulled straight from that standard operating procedure and what other folks have mentioned in previous PowerPoints or the presentations following mine. And that is essentially the who, what, where, when, why, and how of concrete washout. The who, what, and why have been identified, where, when, and how. We're going to follow up in the next PowerPoint here. So what is adequate washout? These are areas designated on site. They're easily identifiable. They're easily accessible. They're away from storm drains and inlets. The residual material is contained. The BMP structure is maintained, and the material is properly disposed of. And there are two things a regulator is going to look for. And one is it implemented? And two, is it maintained? Those are the two keys to being compliant. So washout design, we go into the design. This doesn't necessarily pertain to the drivers, but we want to cover all of our bases here. So if you're a contractor, an engineer, that you're familiar with BMP plan or stormwater pollution prevention plan, these are some of the designs you'll see. Here we have a CAD drawing, essentially, and you'll kind of get an idea that there's really more ways to approach this, that the end result's the same, both from an economic standpoint and a practical standpoint. So here we have hay bales that are being utilized for containment. There's going to be a 12 mil plastic liner. There's information regarding signage being posted. So this is an example of what would be a considerate design for adequate washout. Here's another example. This is an inert containment. So the excavated material is used for containment around the structure. And then we're seeing these on larger sites, and that is these roll-off structures. And the reason being is that they're pretty easy to maintain. They last a long time. And if you're on a larger project, they're really easy to relocate. You just hook them onto a piece of equipment and drag them across the property to wherever the concrete activity is going to be taken. So this is the basic design, but what's more important is what should our drivers be looking for? And the idea behind this is that a picture is worth 1,000 words. So here in this image, we have what seems to be some type of containment, probably straw bales. The contractor has utilized a plastic liner that is on top of the hay bales and not underneath the hay bales. There's appropriate signage, and it seems that this BMP structure is being adequately maintained. So from a regulator standpoint, this would be considered satisfactory. Here is another image of that inert practice, and that is that the excavated material is used as containment, and there's appropriate signage, and it appears that it's been maintained. So this would be considered satisfactory as well. We also have in these roll-off structures, and that's typically what these look like. But I think what's more important than what our folks should be looking for, it's a lot easier to be non-compliant than it is to be compliant. You're getting calls from dispatch when you're getting back to the plant. You need to go out the more time you take up, the more the production side kind of gets on you. So these are the things that our folks should avoid, which I think is more important. Here in this image, you can see, and that's another thing, it's pretty obvious to see where these activities take place. The residual left behind, especially if you're using a dyed product. The last time I checked, creeks aren't typically to run red. So it's pretty easy to identify where these activities take place. So either inadequate maintenance of a BMP was performed. This contractor at least put some type of barrier around the inlet, it seems. However, because concrete washout is a required best management practice, if it is not implemented and it is not maintained, it's a violation. So here we have a similar instance where the contractor is utilizing a hay bale for containment, a plastic liner to contain the residual. However, this BMP, like I said, has not been adequately maintained, and therefore it is subject to violation. And then in this last photo, you could say an attempt was made. Now, regarding enforcement on not utilizing these BMP structures, in the state of Kentucky, for a state inspector, this is potentially 3 violations. One is failure to implement, maintain, or utilize best management practice. 2 being pollution of the waters of the Commonwealth, and 1 degradation to the waters of the Commonwealth. And those 2 go hand in hand. One is a law and one is a regulation, both subject to $25,000 per day or 5 years in prison. It's not likely that it gets to that, but that's how the law reads. So we also go into practices that are absolutely unacceptable and what our drivers are taught not how to utilize concrete washout, and that is dumping it out just on the ground. The problem necessarily isn't the solids here, it's the residual. I mean, you got to think of the admixtures that we put in our concrete, retarders, accelerators, dyes. Once that product becomes diluted, it's free to run wherever it wants. And Mike previously mentioned, it takes a bunch of nasty stuff. So our folks are told that this is not adequate and it's absolutely unacceptable. Same thing, we cannot discharge into an inlet, a creek, a stream, a ditch. We are to use adequate washout areas only. So what if adequate washout areas aren't provided? And that's a pretty easy fix. That is, we supply our own. We utilize these portable washout bags, and these bags fold up and they're stored in the cab of the truck. They do not impede the driver whatsoever, but they have access to it if adequate washout areas aren't provided. And we see this common, excuse me, in smaller pours, mostly residential. And similar to larger construction sites, there's more than one way to tackle the issue to reach the same objective, and that is, this is just a cardboard box with a plastic liner. These both vary in price, and from the perspective of an inspector, our goal is to make sure that concrete washout doesn't reach an inlet or receiving stream. I mean, if you wanted to, a kiddie pool from Menards would probably work. Now, not to say that you're going to put a kiddie pool in your best management practice plan, but essentially it serves the same purpose of containing the residual. Now, these vary, like I said, in cost. These washout bags are typically around $40, and these cardboard containments are somewhere around 15 or 20. The one problem that we are running into utilizing this, and any of you folks that have been around concrete washout and utilizing these bags, is that typically it's the responsibility of the contractor or the property owner or homeowner to dispose of these. The problem being that once it solidifies, it can weigh anywhere between 100 to 250 pounds. And that's a pretty difficult task if you don't have a piece of equipment or you have to do it by yourself. So some alternative practices, in some areas, these are a requirement. It's just, the regulations vary from state to state or community to community. And in some cases, concrete washout residual cannot be disposed of on site. It has to be taken back to the plant and properly treated and disposed of. So in that case, you typically have to retrofit or modify the truck by some means to capture and contain this material. So here we have to where that retrofit. So when the driver gets done, spraying off the hopper and the chute, the residual material runs down into this containment to where it can be taken to the plant for proper disposal. This is a similar piece of equipment that attaches to the end of a chute. So the driver will spray off the hopper and the chute. All the residual material will end up in this containment. However, what varies here is that the residual is pumped back to this containment, and usually the solids can be disposed of on site to where that wastewater is then taken back to the plant and disposed of properly. So those are some, like I said, I briefly want to talk about why IMI and a lot of producers don't utilize these. One, because it's not necessarily a requirement in the areas that we operate yet. I say yet because laws and regulations are subject to change. Not only that, it's another piece of equipment that we have to maintain. And because it's, dealing with water, it becomes really problematic in the winter times. Not only that, because this is another piece of equipment that our drivers have to utilize, there's the potential for injury. And we want to make sure our drivers are safe. So we want to prevent injury. So those are the two main reasons why we don't utilize this type of practice. Now, since we don't have a representative from the state of Kentucky, I've reached out, and being a former inspector, they did not mind that I briefly touch on the enforcement action. So an inspector for the state of Kentucky will usually issue a letter of warning. And kind of to touch on my example of the laws of the road, enforcement regarding the laws of the road is subject to the police officer. The same can be said for environmental regulation. It's subject to the inspector. So, if you get pulled over, you might be given a warning or you might be given a citation. So the same can be said for an inspector. Usually it's outlined in a letter of warning, which is just forced remediation in a given time. Beyond that, depending on the severity, you can be issued a notice of violation. And usually that's forced remediation and potentially a civil penalty. Like I said, our violations are subject to up to $25,000 per day per violation. That's what it, if you've ever received a notice of violation from the state of Kentucky, you're familiar with that verbiage. So it certainly can add up quickly. Stop work orders, usually our local municipalities, city, county, and our MS4 participants have the authority to issue stop work orders. The only, I believe, authority that the state has is if environmental response team responds and there is some criminal action that's taking place. With stop work orders, work is prohibited until remediation is complete. Now, the thing with stop work orders is that it might take you a couple hours to complete the remediation, but it might take that inspector a couple days to return to the site to see that it was completed to remove the stop work order. So you certainly don't want to be the cause for the issuance of a stop work order. You'll be the kid on the playground nobody wants to play with. So stop work orders usually come with a civil penalty, usually between $500 to $1,500 is usually what that civil penalty is. Now, agreed orders, these are kind of a different animal. So if you are given a notice of violation and sent to the Division of Enforcement in the state of Kentucky, Division of Enforcement will typically do a review. And in that review, if you have repeat offenses, you may be asked to enter an agreed order. And so an agreed order is usually forced remediation, initial civil penalty, and then stipulated penalties. So for example, say you're sent to Division Enforcement, they do a review and they identify that you've had 14 violations over a 5-year period for the same thing. They'll ask you to enter an agreed order, and you'll have forced remediations that you'll have to do. And usually the stipulated penalties are anywhere between 20 and 25% of the initial civil penalty. So say that civil penalty, once you enter the agreed order, is for $20,000. Well, the stipulated penalties are per violation. And like I said, since there's potentially 3 violations for every incident of not adequately using concrete washout, you can see where it adds up pretty quick. So that's kind of the perspective if you're forced to enter an agreed order. Worst case scenario, you're considered a bad actor, your permit is revoked, and you're no longer allowed to operate within the state boundaries. This is rare. Usually it is from a criminal standpoint of enforcement. And typically those fines can be of the hundreds of thousands of dollars and jail time. So with that, that's all I really have. I'm kind of interested. I've only been with IMI on this side of the industry for a couple months. But if there are other producers, if you don't feel free, contact me, let me know what you're utilizing. what you've implemented, what your successes and failures were. I'd greatly appreciate it. Not only that, I still keep in touch with the regulatory community here in Kentucky. So if any of you guys have questions, feel free to reach out. And if I can't give you an answer, I can certainly point you in the direction of somebody that can. So thanks again, and I appreciate your all's time. And with that, I'll pass it on to the next presenter.
Thank you, Jordan. And I'm going to go ahead and share my screen. Okay. And is my screen showing up okay?
Yes, it looks good.
Perfect. Thank you. Thank you. Thank you. But I want to thank Hamilton County Public Health and SD1 for our opportunity today to speak to you all. I'll say from an industry perspective, this is something very important. It happens day in and day out as our producers are out supplying concrete for projects. And it is a very important topic that we're talking about today as we're getting really gearing up to hit high construction season. But just want to reiterate one thing that Jordan was doing. He kind of highlighted how they're training their drivers, sales personnel, plant managers, and whatnot. But from an industry perspective, like Jordan kind of stated, as part of your pre-construction meeting or your pre-construction checklist that you might have internally at a producer's operations should include identifying where the washout is to occur. But I'm here today, I just want to give you some brief facts and figures, some national, some international, and some local, but then also highlight some of the beneficial reuse that we've got with concrete washout, not just the water, but also the suspended or the solids that are in the washout. But like Ryan said earlier, the amount of concrete washout material and wastewater generated each year accumulates to 30 times more concrete that was used to build what was considered the Sears Tower, now the Willis Tower, which utilized 2 million cubic feet or 72,000 cubic yards of concrete. Ryan also did highlight that it is enough concrete to build an 8-lane highway 175 miles. But for those of us here in Greater Cincinnati, Northern Kentucky, and where I am in Central Kentucky, that's about a 16-mile highway between Cincinnati and Lexington. Now it's also 75%, almost 75% of all the concrete that was used to construct the Hoover Dam. And again, highlighting Ryan, it's about 50,000, that's water to provide 50,000 people 3 months of their supply. But specifically for concrete, because concrete is versatile, durable, economic, it's the world's most used product, only second to water. In the US, we average about a little over 1 cubic yard per person in the United States. That being said, in 2020 specifically, the US consumed almost 378 million cubic yards of concrete. Of that 378 million cubic yards, for Kentucky and Ohio specifically, our two states combined used over 16 million cubic yards of concrete. For nationally speaking, if you average out 10 cubic yards per truckload, that's about 38 million trucks of concrete each year. And for an industry average, we kind of estimate, and this is coming from national as well, that when you pour a truck full load of concrete, you have about a 1/16 of a yard left on your chutes or in the drum if you discharge all the concrete out of the drum. So that equates to about 2.36 million cubic yards of concrete alone just left on the chutes and in the drums. Because of that, that equates to almost 5 million tons of concrete, which the average cubic yard of concrete weighs about 2 tons. And when you wash out, that then nationally speaks to about 260 million gallons of concrete wash water generated, or about 7 gallons of water per truck chute. So these are why the washout procedures and practices are very important. To highlight here, a lot of people see concrete washout as a hazardous material that needs to be disposed of. Well, I want to kind of switch the ball and make you think a little bit outside the box in, can we reuse it? Concrete washout is 100% recyclable if it is properly managed at the construction site or back at the ready mix plant. Nationally speaking, in some parts of the US, there are shortages of aggregate and sand. So how can we reuse our finite resources? How can we properly and legally reuse them and recycle them? So if it's completely contained, like on site, like what Jordan showed you with the bags, the bins, the new movable bins, those metal bins, if it's removed from site, it can be safely treated and then fully recycle the concrete solids. And those solids can be reused for roadbed or other construction uses. And this enables a large volumes of landfill diversion while polluting wastewater is contained and treated. So reusing the washout water. So if the solids are removed through usually a filtration system or back at a plant, if they have a reclamation system, they can then reuse that water either at the construction site if it's filtered through a filtration system on site for further washing of equipment and chutes, or back at the plant, it can be reused in the manufacturing of new concrete or in other water uses back at the plant. Finally, in some places of the US, if it is treated properly off-site, California is one of them, it can then be delivered to a wastewater treatment plant where it can go through the processes of at the plant, the wastewater treatment plant. So some beneficial reuses of the hardened concrete, the wet concrete, or the washout solids, because as we all know that you may have someone say, hey, I need a 10-yard load, but they actually only needed 7 yards. So you've got an extra 3 yards in some instances. So back at the plant, they can that either wet concrete or the washouts and all that can be screened and separated and reused for other construction sites, returned to the ready mix plant and washed into the reclaimer, and then reused into the making fresh concrete as aggregates. The reclaimers with your settling tanks can separate the cement fines from wash water and reuse in new concrete. So you've got the cement fines, and then you've also got then your fine and coarse aggregates. When the washout water has been removed or filtered out, or it's allowed to evaporate, that hardened concrete can be then crushed and reused as construction material, like I said, as aggregates for a road base, construction fill material. One thing that has been used here beneficially in Kentucky, after talking with some of my members, is when they do that back at the plant, that hardened washout material is reutilizing crawl spaces. Reason that a lot of people like it in their crawl spaces over just regular aggregate is because of it being a kind of already a concrete material. It still has the cement in it. As time goes on, that crawl space base will end up hardening a little bit. So you don't have the shifting of just if you use regular aggregates under your crawl spaces. I'll say in Northern Kentucky, I do know there are places within SD1's jurisdiction that this is being used for crawl spaces. But then that unused concrete that might be in the drum still can be returned to the plant and reused in precast products. You see like the lawn or the retaining blocks, those large blocks that you might see that line a concrete plant or line a construction site, or even you've seen some as reinforcing of stream banks. So they use them for that. They can reuse it to pave the ready mix plant's yard, or again, washed into the reclaimer or dumped on an impervious surface. And I'll highlight that dumped on an impervious surface, so like an existing concrete pavement, and allowed to harden so then it can be crushed and recycled as aggregate. Now I threw this in here. If you Google search EPA concrete washout, one of the documents you'll find is this chart is included in one of those documents. It's the EPA Stormwater Best Management Practice concrete washout, just to show you that there is some beneficial reuse of this product. We here in the concrete industry, and especially nationally speaking, we are doing our greatest efforts to reduce our global warming potential, our carbon impact to the world. Our industry has committed to being net zero carbon by 2050. So when we get to reuse these limited resources again, just as better for our planet, it's better for our industry, and better overall. And that was just a brief highlight of some of the benefits that we've got. But again, I do want to reiterate, like Jordan had said, that as a producer, before you send a truck out to a project, if you do have an internal pre-construction checklist, or if you have a pre-construction meeting with the construction management, the general contractor, one of those items should be identifying where is our washout location. So with that, thank you again to Hamilton County Public Health and SD1 for this opportunity. We do appreciate it. On the screen, you'll see here, I have my full contact information. Should you need anything or have a question or want to talk to me further, please let me know. I've included my office and cell number on there. So if you don't have it, go ahead and jot it down. But thank you, and I will stop sharing my screen so that the next presenters can continue on.
Okay, can everybody see the presentation?
Yes, Olivia, it looks good.
Okay, so I'm Olivia. I'm one of the inspectors with Hamilton County Soil and Water Conservation District, and I'll be doing the first half of the presentation. And then I have Aaron with me, and he is also one of the inspectors for the district. So we'll be giving a little overview of concrete washout. Some of the things will be repeated, so kind of be a summary, but we'll get into it. Okay. So today I'll talk about the Hamilton County earthwork regulations and some of our enforcement, the roles of site supervisors and concrete companies, and a general overview of washout containers and maintenance. So the regulations and enforcement. So Hamilton County Soil and Water Conservation District adopted our own set of regulations based on the OEPA General Construction Permit and the MS4 requirements. So along with inspecting sediment erosion controls, we also inspect a variety of non-sediment pollutant controls like concrete washout. So in our regulations, sections 312 and 316, so they require us and give us the authority to ensure compliance with concrete washout and concrete washout containers. So the concrete washout containers must be installed at any site where concrete pouring is occurring. And as Ryan mentioned in his presentation, a SWIP is always submitted with any project, and that should be outlined on the plan of where the concrete washout should be located. And then section 319 of the Hamilton County earthwork regulations, that allows our district to proceed with enforcement if the concrete washout container is not installed or if it is not maintained. So through this process, we can issue stop work orders, notices of violations, and if necessary, we can get the OEPA involved. So the site supervisor and concrete washout company's role. So it's kind of been previously mentioned, but we'll go over it again. So when someone orders concrete, the company should ask that site supervisor if there is a concrete washout on the site. And the site supervisor should make sure and plan ahead to have that concrete washout container installed. I have heard from many site supervisors, when I ask them why a concrete washout is installed, they say the companies are behind. So it's really important to really plan ahead and make sure that the washouts can get there way before any pouring is done. So the washouts should be in an easy to access location. They should be away from the streets and the curbs so that if any washout does happen to overflow, it won't get into the curbs and streets and end up in the catch basins. According to the Rainwater and Land Development Manual, the washouts need to be at least 50 feet away from any storm drains. And the washouts should be placed in a flat spot so that there is less chance of them overflowing on one side, and then that'll allow them to hold more of the concrete washout. And the concrete washout should be inspected regularly. Our regulations require that the entire site is inspected once a week by a certified inspector. So if anything is damaged or if the concrete washout is full, it will need to be removed and replaced. And the concrete washout should be designated with a sign. As you guys can see down here, there's a great sign that one of the builders had installed. So what you should see on a site. So when the concrete washout trucks are coming on, they should know where they're disposing. If they do not know, they should have the site supervisor's contact information and give them a call if there's any issues. And if needed, you should have your truck be installed with a portable washout station. So that if you have nowhere to pour, you can use that portable washout station. So now I'll pass it on to Aaron.
So on most of the sites that we inspect, these are the two types of washout containment systems that are most commonly used. The straw bales lined with plastic is probably 70 or 80% of what we see on site. We are definitely seeing more of the metal container, waterproof dumpsters, for a better term, being used. And like Brett mentioned, those are definitely a good thing because then all that material can be taken back to a concrete recycler and be reused. Whereas 9 times out of 10, if you're using the hay bales and plastic, that materials end up going to a landfill. Go ahead, Olivia. Occasionally on larger jobs, you will see the pit style washouts. The one that's pictured here was a large industrial building that was being put in. They actually placed this washout under the future parking lot, so they didn't have to worry about removing material. They poured, all the waste concrete, wash water went in there. When they were done, that wash water, they tarped it during rains, and then they also let it evaporate, and then they ended up paving right over it. The other one that's pictured here is your portable washout containers. And realistically, every concrete truck ought to have one of these in it. For your large jobs, obviously, it's probably not real practical. If there's subdivision being put in or a commercial project, you should have a larger designated washout. But for your smaller jobs, if somebody's getting a patio repoured or repouring a driveway in an existing development, obviously they're not going to install a large concrete washout. So having your portable washouts available, it kind of makes more sense for those, because otherwise, where are you going to wash out on somebody's front lawn? That they're not going to be real happy about that. So, the portables we don't see on commercial jobs very often, but it's something that definitely should be on every truck. especially for the smaller jobs. Maintenance. Maintenance is a big thing that we see, or lack of maintenance. So, you know, people don't pay attention to the concrete washouts. It's sort of a second, you know, a last thought type of thing. The plastic blows off because it wasn't secured properly. They get overfilled, plastic gets torn. These are just two photos of the, you know, couple that obviously have not been maintained. The one on the left, you can see where waste concrete has been dumped on the ground, allowed to harden, and then they're stacking that up to remove later. In Ohio, you know, we allow solid, you know, concrete to be placed on the ground if you have excess, but all the wash water definitely needs to go into a washout containment system. Kentucky, you need to have, you know, both the waste concrete and the wash water going into a containment system. Generally, once any containment system is 3/4 full, it's time to either build a new one and decommission the existing, or if it's a concrete washout dumpster, to have it picked up and replaced. You know, the maintenance of them is paramount, because I mean, if they're not maintained and you've got pours going on, the concrete supplier is expecting there to be a washout in place, and they're going to utilize it to the best of their ability, even if it's not functioning. So if you get to a site that doesn't have a concrete washout designated, what should you do? You know, find a spot to dump it on the ground, wash into a storm sewer, wash out into a swale. You know, these are all things that we have seen, unfortunately, on a fairly regular basis. You know, dumping on the ground obviously is the one that we see most often if there is not an appropriate concrete washout installed. Washing into a storm sewer doesn't happen nearly as often as it has in the past, which I definitely have to thank the concrete producers for training their drivers not to do that. With that said, I still have seen that happen. You know, realistically, this is something that should be discussed when concrete is ordered, between the person ordering the concrete and the supplier, as to, you know, is there a place to wash out on site? So if there's not, you know, that's where you use the concrete washout that is on your truck. Whether you want to bill, you know, if you have to use that, you know, if you're the supplier, if you're going to include that in your bill, to, you know, to the person who's getting the concrete, that's kind of up to you. But these are things that need to be thought about before you ever, you know, start a pour or have the concrete truck show up on site. You know, as an inspector, we definitely see good practices, we see bad practices, we see no practices. And, you know, we're always willing to work with people, but because of the potential pollution issues that concrete wash water provides, you know, it's something that we unfortunately, you know, can't turn a blind eye to. There's just too much potential for damage to public infrastructure and to waters of the state, waters of the U.S. So, you know, as an inspector, you know, we will do our part to, you know, make sure that we're working with the developer, the site supervisors, to ensure that these are installed. As a site supervisor, you need to realize that this is an important part of things, and it's not something that's just sort of an afterthought. You know, it needs to be taken care of, because if you as a site supervisor are not providing this washout area, then you're putting yourself, you know, into liability, and also the concrete producer. And it's just not a place we want to see either participant. So say if anybody's got questions for either Olivia and myself, or for any of the other producers or participants in the presenters in this, please feel free to unmute yourself or type into a chat in the chat box any questions that you might have. And you can always feel free, if you're not willing to talk in the open here, contact us, individually after the webinar. More than happy to talk to anybody about these, about any of the stuff that we've covered today. So.
Okay, we have one question that has come into the chat box. Does the city of Cincinnati have different rules, or do the Hamilton County rules apply there too?
So the city of Cincinnati, I don't know their exact rules, but their regulations are going to be based off of the Ohio EPA's general construction permit, just like Hamilton County's are. I would assume that they are going to be, especially for concrete washout, they're going to be pretty much the same. So, waste, like I said, in Ohio, waste concrete is allowed to be put on the ground. Wash water always has to be contained. I would love to see where both of them have to be contained in Ohio, but that is not the regulations at this point. But if I had to say that Cincinnati's regulations are going to be very, very similar to what Hamilton County's are, because we're both basing our regulations off of the state regulations.
And I think I'd add that the same is probably true for Claremont and Warren and Butler counties. They're all based off the construction general permit, so they all should be pretty much the same.
Mm-hmm. It's always worth checking with the municipality you're working in, because obviously they can't be less stringent than what the state regulations are, but they could be more stringent.
Any other questions for our presenters, either the ones you just heard from, or for Ryan and Matt, who you heard from earlier in the webinar? Okay, well, it's about 10 to 12. I don't see any questions coming in. Sarah, you don't have any, right?
I do not, John.
Okay. I think with that, we'll wrap up the webinar. I want to thank again all our presenters for sharing information today. It was very useful to me. I hope it was useful to everybody that participated. Another big thanks to the Ohio and Kentucky Concrete Associations for helping Save Local Waters organize the webinar. And yeah, I appreciate everybody attending, and I hope you got something out of it. Feel free to reach out to our presenters after the webinar if any questions come to mind. All right, thanks everyone.